And welcome everybody to the Daily Space Weather. We're looking at the sun here. We see only one sunspot and low levels of solar activity. This is the 171 angstroms wavelength from the Solar Dynamics Observatory. I, by the way, am your host, Dan, aka smAsho. Take a look at the colorized magnetogram to see the degradation of sunspot 2824. The umbra there has stayed pretty stable. It's going to be degraded to an alpha class sunspot today if I had to guess, which I don't. Here's another wavelength, 193 angstroms. And we saw brief geomagnetic storm conditions yesterday. Expecting calm conditions for the next couple of days. We'll get to the forecast momentarily. There still is a possibility for coronal mass ejections. There are some plasma filaments in between the Earth and the Sun right now. Here's a chart of the solar system. There's where things will be in a week on the 28th of May. And you're in the 60 sunniest days of the year, as we've got 30 days until the solstice, or the darkest days if you're in the southern hemisphere. Here's a star chart. I like to face mine to the south and draw in the ecliptic. That's in-the-sky.org if you want to make your own. And the 10.7 centimeter radial flux all the way down to 72 solar flux units. There's the 1 year chart of that. It's the black line. The red line below that is the sunspot number, and the blue line below that is the Potsdam AP Planetary Magnetic Field Index. There's the NOAA forecast for geomagnetism, and not expecting any geomagnetic storms. No coronal mass ejections headed our way. Let's take a look at seismicity. We're seeing a continued earthquake drought for 7+ magnitude earthquakes. We're over 2 months here without a 7 magnitude earthquake, so we're way overdue for one. And here are the 5 magnitude quakes over the past 24 hours. Let's scroll up the list. No major quakes over that period, although a string of them north of Australia there, including some deep quakes like this 4.4 at the Philippines and this 4.5 at Timor-Leste. That one over 550 kilometers depth. Also a deep quake at Fiji, a 4.4 at 373 kilometers. And I'm just going to scroll the list. If we miss anything, let us know in the comments. Also a 5.2 at Chile at 120 kilometers. So some deep quakes kicking off there. And also a 4.4 near Fiji at 640 kilometers. Papua New Guinea saw a deep quake. And Mount Etna has been producing another paroxysm, another lava fountaining event there. Photo credit to Georgia Costa. Let's see what else is on the volcanic list. And first on the list is the Sicilian volcano of Etna. Yes, another paroxysm. Returned around 1:30 a.m. local time. Strombolian activity. Not sure the altitude of the volcanic ash cloud. Please don't hang glide over Mount Etna. I doubt you'll be able to unless you've been towed by an aircraft. Mount Abiko also producing a 14,000-foot plume of ash. Mount Manam in Papua New Guinea back on the list as it explodes, 7,000-foot ash plume above it. Semeru on the Indonesian isle of East Java, 14,000-foot ash plume there. Dakono exploding, 7,000-foot ash plume there. On Halmahera, Samisa Pochnoi in the Aleutian Islands, still erupting, enough to produce a 10,000-foot plume of ash. Flight level 160 over Fuego in Guatemala. As it explodes, it produces a 16,000-foot plume of ash. Sangay exploding, 20,000-foot ash plume there in Ecuador. Revenador in that same country also exploding, 15,000-foot ash plume there. And Sabancaya reminding us not to pole vault the caldera as it explodes and produces a 21,000-foot plume of ash. Whatever you do, don't pull a Steve Stimpak. Do not pole vault the caldera. This public service message brought to you by smAsho.com. By the way, I'm wearing the Do Not Pole Vault the Caldera socks today. I would model those for you, but it's not going to look very well with my key frame and so on. So in any case, do not pole vault the caldera. We saw some minor flaring here, some B-class flares, no major flares. Those likely coming out of Sunspot 2824. No proton strikes. There's the GOES proton flux over the past 3 days. Here's the GOES magnetometer over the past 3 days, and we're seeing some spiky sawtooth patterns here. We did see a coronal hole wind stream yesterday. That's what's responsible for these little sawtooth spikes here. And that coronal hole wind stream looks like it is subsiding now a little bit. We'll get to it. Here's the top view ecliptic plane. I'll try that again. It's the top view ecliptic plane field plot. And we do see some activity out here by stereo A. There is another active region trailing Sunspot 2824. We're starting to finally see a little bit of it coming over the limb on the northwest. We'll show you that later in the video as well. Here's a line of sight ecliptic plane field plot showing you the magnetic fields. And we do see some B field migration here. We'll show you that on the next frame. Here's the sun's B field shown in blue, as well as coronal holes shown in green for North Pole oriented coronal holes and red for South Pole oriented coronal holes. And again, you see some migration of the B field showing up here as cycle 25 takes its good old time progressing. And there's the latest image. We are getting quite close to the North Pole oriented current sheet. In fact, the Earth is ready to snap across now, probably already in the process of doing so. So look for some spikes in the GOES magnetometer. From that, you can see the Earth's potential field surface source line here just about to move into the North Pole oriented current sheet shown in green. Next, looking at detected filaments and detected sunspot groups. Sunspot 2824 is an alpha class sunspot, or soon to be designated as one. And we're really not seeing filaments showing up very well here on the detected filaments. We'll just move on here. I would assure you that there are some in between the Earth and Sun right now. Continuing on, the KP index currently at 2. And for you new viewers, thanks for tuning in. The KP index is a measurement of global geomagnetism. Next, we'll take a look at the real-time solar wind to see what's driving that KP index. And we see a slightly elevated solar wind speed continuing here, actually near the highs. So maybe an extended coronal hole wind stream here, nearly 600 kilometers per second at 589 kps. Solar wind density, just over 6 protons per cubic centimeter. And here's the Geospace. It's 4 hours of Geospace magnetosphere movie. And thanks for commenting, John. This empty space right here, this empty looking space, that is the plasmasphere. These are normal. And during periods of geomagnetic storm, we see additional Van Allen belts get created. We also see changes in the plasmasphere as a result of changes in the solar wind regime. Anyway, that's 4 hours of data. Here are ground magnetic perturbations. And we see some significant magnetic perturbations to the Earth's B field here in places like Antarctica south of South America. Also some magnetic perturbations here over Alaska, the Siberian North Pole. Anyway, like the last Geospace magnetosphere movie, that's 4 hours of data. Some magnetic pulses coming out of the Pacific Ocean there as well. Next, I would remind our YouTube viewers that we do regularly stream live to Twitch. It's twitch.tv/smAsho, and welcome Twitch viewers. We're actually streaming live now. It's our Cosmology segment, and we love the Twitch platform, twitch.tv/smAsho. Thanks to our followers over there. Thanks to our new subscribers over on YouTube. Don't forget to press like and subscribe if you are new to the channel. Share the content with your friends and foes on social media. We're also on BitChute. There is exclusive content there. Thanks to our patrons, the real source of funding for the content, as we make just this side of nothing on YouTube. So again, please share the content. Consider becoming a patron. You'll get all kinds of early alerts, multimedia, and other perks for being a patron. Thanks to our patrons, you are increasing the probability that these videos will continue to exist and be publicly visible. Check out our mission also at smashamash.com/forum/mission. You can find links to the forum there as well as our smAsho merch. Again, today's featured product is the Do Not Pole Vault the Caldera socks. So if you click on smAsho merch from our homepage at smashamash.com or get redirected from smashamash.org, you'll find this. And the featured product, again, is the Do Not Pole Vault the Caldera socks, featuring the image of Steve Stimpak pole vaulting a caldera there. And also check out our forum. There's a Cosmology forum there and so on. Let's do our Cosmology segment. One of the forum threads in the Sun forum is Grand Solar Minimum. Why? Because Grand Solar Minimum figures into Cosmology as we're not really fully well. We may understand the mechanism behind the solar cycles, but in any case, let's just put a pin in that until later in the video. Let's do the Cosmology segment. We'll pick a random number. Today's random number is 316. Let's see what that coincides with. It's some object at Neil Gorell Swift Bat X-ray Observatory. It's supernova 1993J. So here are the X-ray outputs from that supernoval nebula. And let's see if we can get a look at this one. Supernova 1993J. Let's see if we get a great nebular cloud around this one. And there it is on Aladdin Light. It's in the outskirts of a galaxy there. And let's see how this shows up in different wavelengths. So nothing showing up on the infrared spectrum there. Let's take a look at it on the X-ray spectrum on Chandra. And it's a very interesting X-ray source there. It's got some great gradation of the X-ray flux from that. Does it show up in blue light? Not really. How about in UV? So anyway, there it is on the Chandra. It does show up on the XMM Newton multi-mirror project as well. Supernova 1993J, today's random cosmology object. Today's astronomy picture of the day comes from the 1976 Mars landing Viking mission. Yes, the Viking 2 lander produced some imagery on the surface of Mars. And this photo's about as old as me, from 1976. Great image of that. And let's talk about fast radio bursts. Where do they come from? What's up with fast radio bursts? Here at the Smash News Network, least busted name in news, we are interested in this sort of phenomenon. And here are 4 different fast radio bursts from 4 different galaxies, represented in these elliptical circles. And where do they come from, folks? They seem to come from magnetars. So magnetars are a specific type of pulsar with a very, very strong magnetic field. And without getting too in-depth into that and causing blasphemy on the channel by talking about things like neutron stars and neutron stars with very strong magnetic fields known as magnetars and pulsars and so on, I'll just let the article scroll here. This is from SciTech Daily. Are you really surprised that fast radio bursts are coming from magnetars? I don't find it all that surprising, but I guess that's a breakthrough. And this is imagery from the Hubble Space Telescope. The article's from scitechdaily.com. Probably my favorite science publication. And feel free to pause the video if you'd like to read the article. We'll be here when you get back. It's the beauty of video on demand. That's SciTech Daily article. And that's today's Cosmology segment. We'll have to say goodbye to Twitch. It'll be exclusive on Twitch as a separate video, otherwise included in the daily space weather, youtube.com/smashomash. And time to continue on with the DSW. Let's talk about Van Allen belts and electrons. Here's a diagram of the Van Allen belts. We don't see major charging hazards, little minor charging hazards over northern South America and Central America. Here's the 1-year chart of the electron flux. Earth is surrounded by bands of electrons. There's the 1-year graph of their density. Here's a 3-day chart of the density. There goes electron flux. And we're seeing more moderate levels here. The forecast is for a little uptick in the electron flux. I would tend to agree with that forecast there. The green boxes are the forecast. The yellow diamonds are the observation. Here is the total electron content visualization. This will show you where GPS errors are most likely to occur, typically on around the equator at noon. And that should give you a good idea of where GPS errors are likely to be located. This is showing you electron density throughout the entire air column. Speaking of the air column, here's another view of it. Distances are in kilometers on this diagram. Here is the ionogram of the past 2 days, courtesy Australian Government Bureau of Meteorology. And we do see some fast pulsations happening here in the ionosphere. You're looking at vibrational frequency here, measured in millions of vibrations per second, megahertz. Some rather rapid charge ups here actually in the ionosphere. And let's bring up the latest image. There's the latest image from 8 o'clock Universal Time. Here's your weather.gov map. And today's meteorology segment will be integrated in the daily space weather video. We see winter storm warnings and freeze warnings over western Montana, as it is still snowing there, despite it being May 21st. Let's take a look at surface winds. Here are surface winds of the eastern world. And we see turbulent winds here south of Australia continuing. Here are the jet streams of the east. And we see doubled up jet streams in both hemispheres and backward jet streams over the central Indian Ocean. Here are the jet streams of the western world. Extreme meridional jet stream flow here. Check out this N. It doesn't stand for Nigro. It stands for, I don't know what it stands for, but it's a giant meridional jet stream flow situation. Jet stream blowing due north and due south over places like North America. Also doubled up, tripled up jet streams in the southern hemisphere. Here are the surface winds of the western world. Next, I'd like to talk about the grand solar minimum. So check out this chart here. This is 1,000 years of solar activity. And we've placed this on smashomash.com/forum in the Sun section, the Sun forum, about the grand solar minimum. And what we're talking about here is 1,000 years of solar activity. So here is the proxy data. And note how consistent over the last 1,000 years solar activity has been, at least according to cosmic ray flux. Does this give us insight into the mechanism behind the solar cycles? Notice how tight the range is of solar activity. So the likelihood of any extreme reduction or increase in solar activity is quite low. As you can see, over the past 1,000 years, the range of solar activity is pretty consistent here. So I just wanted to give you a little tidbit about that, folks, as we talk about climate on the regs on the channel. Let's get back to weather. And we're seeing some thunder here. Actually, we're not seeing thunder. We're seeing, you get the idea. Anyway, we're seeing some terrestrial lightning here in the northern U.S. here, places like South Dakota. And we'll zoom back out to show the global lightning map here, lightningmaps.org. I go there when I hear thunder. And here's the NASA GOES lightning mapper for a visualization of it. Southern Mexico seeing some extreme lightning once again. And in the U.S., the main lightning is in North and South Dakota, having just moved in there from Montana. Let's take a look at some more data here. How about snow depth? Yeah, it's still snowing in Montana, for real. So there's the current snow depth, and let's advance this into tomorrow. And you can see additional snow will have fallen by 1 p.m. tomorrow. That's 1 p.m. Eastern Daylight Time. Montana about half covered in snow by then. Apparently, folks, it's so hot that it's cold. It's so hot that it's cold, folks. So here is the U.S. Doppler radar map. And you can see the entire western half of Montana seeing snow. Also, Nevada seeing snow on May 21st. Oh my God, it's so hot that it's cold, folks. It's so hot that it's cold. Here's what's going on in the cloud layer. And you can see that the effects of that extreme meridional jet stream flow here as air is moving from south to north just west of the Mississippi Valley there. And there's the water vapor map to make it even more clear. And actually, it looks like a lot of that moisture is going to be pushed up into Canada there as a result of that dry mass of air providing an impulse from the south. And that's today's meteorology segment. It's been dovetailed into the daily space weather. And let's take a look at some bonus features. First bonus feature is the El Teide ground-based solar observatory, El Teide, Spain, looking at the sun in hydrogen alpha, 6,562.8 angstroms. And you can see some of the filaments that we talked about earlier. Here is one. Remember, folks, we don't need solar flares to see coronal mass ejections happen. You can see some filaments down here in the south as well. And we've got some additional solar imagery. Here's what we saw during show prep, a degradation of Sunspot 2824. Let's press refresh and check out the latest data. And there you can see barely any trailing umbrae there. In fact, I think that's already alpha class, as those look like they are North Pole umbrae, shown in blue as well. Here are some additional animations of the northern hemisphere. A great Earth scale there in comparison to Sunspot 2824, as well as the North Pole-oriented coronal hole in 193 angstroms. We'll also show 304. Large filament there right toward the center of the screen. Again, possibility for coronal mass ejection still there, folks. And we'll close things out at 171 angstroms, my personal favorite wavelength. Thanks for tuning into the Daily Space Weather. And may that solar wind be at your back.